Hello everyone. In today's lecture, let us learn about different connecting devices used in computer communication networks and about virtual LANs. In my presentation, I have two sections. The first section deals with different connecting devices like hubs, repeaters and their features, link layer switches, and how these will create loops when connected to a broadcast domain. And second section deal with virtual LANs. In that we'll see how a membership can be defined in case of a virtual LAN, how it can be configured, and finally the advantages of having a virtual LAN. LANs usually not operate in isolation. So to communicate between the devices in a LAN network, device will be used to connect these devices or to connect to a network. These connecting devices can operate in different layers of a internet module. Here we'll discuss about three different types of connecting devices. As you can see in the slide, there are three different devices will be used at three different layers of a internet protocol. Hubs operate in first layer of internet module. Link layer switches operates in first two layers, and routers can operate in first three layers of a internet. First we'll see about hub and repeaters. Hub is a device which can operate only in physical layer. Signals which carry information can travel to a fixed distance and then the signal will get attenuated. So the hub or a repeater receives a signal, and before it becomes too weak or corrupted, it is going to regenerate the original bit pattern and it is going to forward the frame or the signal. Whereas hub and repeaters does not have or does not check for link layer address of a received frame. Their work is to just regenerate the signal. Next one is link layer switch or bridges. Link layer switches operates both in physical layer as well as in data link layer. In physical layer, it regenerates the signal as it receives, and as a data link layer device, switch will check for the MAC address contained in the frame. Let us see what is the difference in functionality of a bridge and a repeater. As I said before, a repeater will just regenerate the signal, whereas bridge regenerates as well as it will check for the MAC address. It means a bridge has a filtering capability. So it can check the destination address of the frame and can decide from which outgoing port the frame can be sent. Each bridge has a table that maps address to the port. Let us see one small example here. We can see a LAN network here in which four devices are connected through a switch, and you can see a switching table there where you have address as well as the port address. If a frame destinated for station 71.2b.13.45.61.42 arrives at port 1, then the link layer switch consults its table, or it will check it in the table to find which is the departing port. As per the switching table, frame for 71.2b.13.45.61.42 should be sent out through port 2. So each time whenever a frame arrives, the switch will check with the switching table and decide through which port the packet has to be forwarded. Similar to the normal bridges, there are some special kind of bridges which we call it as transparent bridges. Transparent bridges or switches are the one in which stations are unaware of the switch existence. So if a switch need to be added or deleted from a system, the reconfiguration of these systems are unnecessary. So whenever the bridges are added or deleted, automatically the configuration will takes place. So whenever we use any transparent bridge, as per IEEE 802.1d specification, system with transparent switch should have three special criteria. The first criteria we say it as forwarding, that is frame must be forwarded from one station to another. Second one we call it as learning, that is the forwarding table is automatically made by learning frame movement in the network. And the third one is loop in the system must be prevented. So the transparent bridges which will be used in the network should forward the frame whenever it receives. Similarly, whatever the forwarding table it has got should be automatically updated by a process called learning, and it has to be designed such that there is no looping problem in the system. In earlier switches, switching table were static. That is, the administrator has to manually enter the switching table during the switch setup. If the station is added or deleted, the table has to be modified manually. So better solution is to have a static table to convert it into a dynamic table that maps the address to the port automatically. In order to make the table dynamic, we require a switch that gradually learn from the frame movement. To do this, switch check both the source as well as destination address in each frame that passes through that particular switch. The destination address in the frame is used for forwarding the frame, and source address is used for adding entries to the table and for updating purpose. Let us see how exactly it happens using one simple example. Let us consider a simple LAN network wherein we have four devices which are connected to a switch as shown in this slide. Initially, there is no entry in the switching table as you can see in A. Now, let us assume a station A sends a frame to station or destination D. The frame goes out from all the three ports of a switch. However, looking at the source address, the switch learn that station A must connect it to port 1. That is, if any frame destinated for station A must be sent through port 1. The switch adds this entry in the table as we can see in B. Similarly, when station D sends a frame to B, switch does not have any entry related to station B. So it sends through the remaining ports. However, it adds one more entry to the switching table as shown in C. And this process will continue until the table has complete information about all the address as well as the port. Hope you're clear with the learning process of a switch. Now let's move on to the third one. As I said, the transparent bridges should avoid looping problem. These transparent bridges work fine until there is no redundant switch in the system. That is, not more than one switch connecting the two network. However, system administrator likes to add redundant switches to make sure that system is more reliable. If the switch fail, that is if one of the switch fail, so another switch will take over until the failed one is repaired or replaced. But loop will be created when more than one switches are used or operated at same instant. Let us take this example for understanding purpose. As you can see in this slide, there are two LAN network connected through two switches. You can see here this is LAN 1, this is LAN 2, and these two networks are connected through two switches. So you can see here there is one switch here, and from this side there is one more switch. So two LANs are connected each other through two switches. Let us take station A want to send a frame to station D, or station A has sent a frame to station D. Initially, the tables of both the switches are empty. You can see both the tables are empty. So what they will do is both of the switches will forward the frame and update their table based on the source address. So you can see here both the switches have forwarded the frame to LAN 2, and since it has connected through a port 1, so you can see in both the switching table the data has been updated. Now there are two copies of the same frame in LAN 2. One copy sent by right switch, received by the left switch, which does not have any information about the destination D. So it forwards the frame. Same in case of another switch. The table of both the switches are updated, but still there is no information for destination D as shown in figure C. You can see here, so whatever the frame was received in LAN 2, that is two copies of frame received in LAN 2, they didn't had the destination address. So what it will be done is, so it will be forwarded again back to LAN 1 through these two switches. Now there are two copies of frame on LAN 1, you can see here. So it will forward it back to LAN 2 by updating the switching table. You can see here once again this has been updated and frame will be sent to LAN 2, and this process will go on continuing from transferring the frame from LAN 1 to LAN 2 and LAN 2 to LAN 1 continuously without reaching to the specific destination. According to this example, it has been destinated to device D. So the transparent switch whichever we are going to use, it has to deal with this kind of problem. So it has to be free from this looping problem. So to overcome this kind of problem, we have one algorithm which we call it as spanning tree algorithm. To overcome this looping problem, switches uses a spanning tree algorithm to create a loopless topology. According to the spanning tree algorithm, each LAN can reach another LAN through only one particular path. Without changing the physical topology, only the logical topology is created such that only one path exists between the LANs. According to the spanning tree algorithm, to find the spanning tree, it involves three steps. Let us see which are all the three steps. Step 1, every bridge has a built-in ID. So each bridge broadcast this ID so that all the bridges know which one has the smallest ID. So that the smallest ID bridge is selected as a root bridge. So I'll explain what is that root bridge while solving the problem. Step 2, the algorithm tries to find the shortest path from the root bridge to every other bridge or a LAN. So from the short what do you say root bridge, we are going to find out the shortest path to other bridges or to a LAN. So the shortest path will be found by examining the total cost from root bridge to each of this destination. Third step, the combination of shortest path creates the shortest tree. Let us see the process to find a spanning tree. So this is the example wherein we have five switches S1, S2, S3, S4 and S5, and it is used to connect four different LANs: LAN 1, LAN 2, LAN 3, LAN 4. As you can see here, there are multiple paths from one network to one more network. Okay, so there is a looping problem presently. So now, to reduce or to remove this looping problem, we'll apply the spanning tree algorithm. So as per the spanning tree algorithm, first we need to find out the root bridge. According to this example, we are taken S1 as a root bridge. So this is found out by calculating or checking which switch has the smallest ID. So according to this example, S1 is having the smallest ID. So this will be taken as root switch or a root bridge. Once the root bridge is assigned, now we are going to assign cost for moving from switch to LAN and from LAN to switch. So when we move from switch to a LAN, the cost will be given as 1, and when we move from LAN to a switch, it is given as 0. So you can see here, from switch to LAN it is 1, from LAN to switch it is 0. The same thing has been done in all other cases. If you want, you can see here, from switch to LAN, forward condition 1, whereas from LAN to switch it is 0. So similarly here, so all cases, for all the switches to and to a LAN, a cost will be assigned. Once the cost is assigned, now we need to calculate what is the total cost to reach that particular switch or a LAN from the root node, that is from this particular place. So from this switch to this LAN, to reach this LAN, the cost is 1. So this is 1. The same path I can follow, so I can go to the LAN 1 using one more path. So in this path, cost is 1. From here to here it is 0. So from here to here it is 1. So 1 plus 1, 2. From here it is 0. So it is 2 plus 0. From here to here it is 1. So it is total 2 plus 1, 3. So to reach from S1 to LAN 1, the shortest path is this. So it is going to give me a cost of 1. Whereas if I take this particular path, the cost will be 3. Similarly, we can find out for this particular path too. Here also the cost will be more. Similarly, to reach from S1 to S2, the total cost is 1. This is 0, so it is just 1. If I take this particular path, it will be 1 plus 0 plus 1 plus 0, so it is 2. So the shortest path is this path only. Similarly, we'll do it for all the cases and we'll see which is the minimum cost. There are some cases wherein we'll get equal cost when we move from multiple path. In that particular case, we can choose any one particular path and we are going to neglect or we are going to leave the one more path. For example, if you see, to connect from S1 to to LAN 3, we can go via this path. Here cost will be 1 plus 0 plus 1, so it will be 2. Similarly, if I take this particular path, that is 1 0 plus 1, so it is 2. So I have two options. I can come in this particular path or I can take up this particular path. So it will be decided by the administrator to choose either this particular path or this particular path. Any one particular path will be chosen as a destination. So this is the final solution where we can see from S1 to LAN 1, S2 to LAN 3. So we don't have a link between LAN 3 to S switch 3, because this is going to give me the same cost. Either I can come by this path or this path. So we are chosen only this particular path till LAN 3. Okay. Similarly, as I said, from here to here, this is the one path. Even this is possible, but we have chosen only this particular path. So this whatever we had earlier we called as blocking mode, and rest are in forward or forwarding ports. So using this shortest path algorithm or using this spanning tree algorithm, we are going to calculate the shortest path between the switches and LAN and switches. And this is going to reduce, or it is going to remove the looping problem usually that occurs in transparent switches. Next, we'll move on to the routers, a device which operates in three layers of an IP. So it operates in physical layer, data link layer, as well as in network layer. As a physical layer device, it is going to regenerate the signal. As a link layer device, it routes or check for the physical address contained in the packet. As a network layer device, it routes check for the network layer address. Usually, a router connects LANs with WANs in a internet and has a routing table that is used for making the decision about the routes. So, based on this routing table, it is going to decide in which path the packet has to be forwarded. With this, I'll end up the first section of this particular chapter. So we have seen hub or a repeater, link layer switch, then routers. So in case of two layer switch or bridge, we have seen something called transparent bridges. So what are the criteria it should process, and how to overcome the looping problem using spanning tree algorithm. Let us move on to the next section, which is called as virtual LAN.